So the sample question is, what is the benefit of opportunistic wireless encryption (OWE)? The second topic for the day is .1x in ArubaOS-CX Switches. First, I will go through the scenario and the question, and then we will discuss the process, how it works, and then we will discuss the answers. So the scenario is, an ArubaOS-CX switch enforces .1x on a port. No fail-through options or port access roles are configured on the port. The .1x supplicant on a connected client has not yet completed the authentication. So this is a scenario, and let's look at the question. Which type of traffic does the authenticator accept from the client? Okay, let's look at the sample question. It's a scenario based question. First, let's read the scenario first. Device A is establishing an HTTPS session with the ArubaPedia website using Chrome. The ArubaPedia web server sends the certificate shown in the exhibit. Question is, what does the browser do as part of validating the web server certificate? Topic number 4, end user device certificate. So in an organization, there are two types of devices: domain control devices and non-domain devices. So using Windows CA, we can push certificate to only domain control devices. Microsoft Windows CA is a common option to issue certificate for domain users. GPO, Group Policy Objects, can set up to push certificate to domain join devices and users. Only domain join. So Windows CA and GPO is only able to push certificate to domain join devices and users. So what about non-domain devices? So there are two options for non-domain devices. First option is mobility device managers, but it has its own limitation because MDM can manage mobile devices and can push certificates to those devices. So MDM can only push certificate to mobile devices. What about Aruba ClearPass? ClearPass can issue correct certificate for any device using its onboard module. Onboard can integrate with multiple CA. Onboard can act as an intermediate CA or root CA. So the good thing is Aruba ClearPass. ClearPass can issue correct certificate for any device. So it doesn't matter it's domain control device or unmanaged device, ClearPass can issue certificate. So let's look at the sample question, which correctly describes a way to deploy certificate to end user devices. Hello everyone. Welcome to today's class presented by 591lab.com. During this session, we will discuss topics with sample questions related to the HPE Aruba Network Security Associate Certification exam. Before I move on, let me brief you about the 591 Lab. 591lab.com, pronounced as 591 Lab, is the top IT training and certification exam brand in China, Hong Kong, Taiwan and Singapore. Our mission at 591 Lab is to provide our clients with exceptional exam preparation experience for certifications in Cisco, Huawei, HPE Aruba, Juniper, Palo Alto and Fortinet exam tracks. That's about 591 Lab, and let's move to today's agenda. Today's topic number 1 is Opportunistic Wireless Encryption (OWE), also known as Enhanced Open Authentication. Topic number 2 is .1x authentication in the ArubaOS-CX Switches. In topic 3, we'll discuss how the web browser validates the web server certificates. And the last topic for the day is about end user device certificate management. Hope you will enjoy the class, and let's jump into topic number 1. Okay, let's start with topic number 1, Opportunistic Wireless Encryption (OWE), also known as Enhanced Open Authentication. OWE is defined in RFC 8110. It uses WPA concepts to encrypt communication over Wi-Fi networks even when no authentication is available. Once the device connects to an enhanced open network, the system automatically establishes an encrypted connection. This process requires no password or user interaction, ensuring easy connectivity while maintaining a high level of security. Now let's look at the process of OWE. AP beacons for an OWE WLAN indicate that it supports OWE. The station connects to the WLAN. It passes through the open system authentication. However, the .11 association frames include extra TLV, which carry an unauthenticated Diffie-Hellman exchange to derives a PMK. So the .11 association frame include the extra TLV with unauthenticated Diffie-Hellman, and using this station and AP derive the pairwise master keys. So this is the WPA concept. It derives the PMK and then station and AP move to the four-way handshake process. During the four-way handshake, station and AP derive PTK and GTK. PTK and GTK used to encrypt and authenticate future data. From the user point of view, an OWSSID works similarly to an OpenSSID. The user click connect and the connection happens without the user having to submit any credentials. However, the traffic is encrypted and authenticated. At the end, you can see traffic is encrypted and authenticated. As a summary, OWSSID works like an OpenSSID. Anyone can connect. User click and connect, no credential required. Traffic is encrypted and authenticated. OWE provides best effort security. OWE is subjected to man-in-the-middle MITM attacks. Why? Hacker can use honeypot or rogue AP to collect PMK information. OWE WLAN protect against casual snooping. I hope you understand the basic explanation of OWE. Now let's look at the sample question. So the sample question is, what is the benefit of opportunistic wireless encryption? What is the benefit of opportunistic wireless encryption, OWE? We have 4 answers. Let's start with answer A. It offers more control over who can connect to the wireless network when compared with WPA2 personal. If you look at the OWE summary, it clearly says anyone can connect. So it means we can't control who can connect to this SSID because it's an open authentication SSID. So answer A is wrong. Answer B, it provides protection for wireless clients against both honeypot APs and man-in-the-middle attacks. If you look at the point number 6 and 7, OWE SSIDs are subjected to man-in-the-middle attacks. Hacker can use honeypot AP to collect PMK information. So it doesn't provide protection for wireless client against both honeypot AP and man-in-the-middle attack. Answer C. It allows both WPA capable and WPA3 capable client to authenticate to the same WPA personal WLAN. So it's not a WPA personal WLAN, it's an open SSID. So answer C is wrong. Answer D. It allows anyone can connect but provides better protection against eavesdropping than a traditional open network. So it clearly says in point number 8, protect against casual snooping. So answer D is the best answer for this question. So hope you understand how we select the correct answer. Let's move to the second topic for the day. Okay. The second topic for the day is .1x in ArubaOS-CX Switches. First, I will go through the scenario and the question, and then we will discuss the process, how it works, and then we will discuss the answers. So the scenario is an ArubaOS-CX switch enforces .1x on a port. No fail-through options or port access roles are configured on the port. The .1x supplicant on a connected client has not yet completed the authentication. So this is a scenario, and let's look at the question. Which type of traffic does the authenticator accept from the client? Okay, let's look at the diagram. So in .1x, we have 3 main components: supplicant, authenticator, and the authentication server. In this case, authenticator is ArubaCX switch, authentication server is ClearPass. So radius in authenticator, radius server is already configured with the IP address and the radius secret key. So let's go through the process. So supplicant is connecting to the port where the .1x is configured. So first place, the port is unauthorized. It means port doesn't allow anything to be transmitted by the supplicant except EAP messages. So supplicant is sending EAP messages to the ArubaOS-CX switch. Then ArubaOS-CX switch forward these EAP messages using Radius protocol to the Radius server, to the ClearPass server. Then ClearPass server validates the user identity and it sends either Radius access accept or Radius reject message. In this case, Radius server is accepting the authentication request. It sends the Radius access accept to the authenticator. Then authenticator sends EAP success message to the client, and then ArubaOS-CX switch authorize the port. After authorizing, supplicant is able to send DHCP DNS request and all other communication. So as you can see here, before completing authentication, switch only allows EAP messages. After completing authentication, switch allows port to transmit the DHCP, DNS and other user data. So if you go back to the question again, which type of traffic does the authenticator accept from the client? So answer A, DHCP, DNS and Radius only. So supplicant doesn't send Radius packet, and also DHCP, DNS are not accepted in this stage because client has not yet completed the authentication. So answer A is wrong. Answer B, DHCP, DNS and EAP only. EAP yes, but not the DHCP and DNS. So answer B is wrong. Answer C, Radius only. No, Radius, supplicant doesn't send Radius messages. Radius messages exchange between only authenticator and the authentication server. So answer C is wrong. Answer D, EAP only. Yes. Before complete authentication, authenticator accept only EAP messages from the supplicant. So hope you understand the theoretical part of this process. So let's move to the topic number 3. Okay, let's look at how web browsers validate web server certificate. First, let's discuss the theoretical part. So if you look at this picture here, we have root certificate, intermediate certificate and end entity certificate. So root CAs are at the top of the hierarchy. They sign their own certificate called root CA certificate. Root CAs are well-known entities that are widely believed to be trusted, for example DigiCert and Komodo. Intermediate CAs are responsible for issuing and signing certificate for end entities such as web servers, network infrastructure devices and users. Windows machine comes with well-known root CA certificate already installed on them. So root CA issue few certificate and make intermediate CAs, and then intermediate CA issue certificate for end entities such as web servers, networking devices. So when we have end entity certificate, how we will validate it? So from end entity certificate, we will take the issuer CA. Then we will find the issuer CA certificate using its subject name, and then we will take the issuer public key and verify the signature of the end entity certificate. That's how the validation process happened. If this end entity certificate issued by root CA, then we will take this public key and verify the signature. But in this case, the end entity certificate issued by the intermediate CA. So then we are using intermediate CA public key. So let's look at the real world example. So I'm browsing networking support hpe.com. So the certificate of networking hpe.com issued by DigiCert, and this is the issuer name. So if you browse to the web browser certificate list, you can find the issuer CA. Then what does the browser do is it will take the public key out of from this intermediate CA and then validate this signature of this certificate. So this is the validation process. So in your computer you can browse to the you can open your browser and you can go to settings, privacy and manage certificate. Then you can get all the information of the existing root CS. If you have your own root CA, then you can import those certificate into web browser. Otherwise your internally used certificate will not be trusted until you import those certificates, because private CAs are not trusted by web browsers by default, but well-known CAs like DigiCert, GoDaddy are trusted by the web browsers. Hope you will understand the validation process. Let's move to the sample question. Okay, let's look at the sample question. It's a scenario based question. First, let's read the scenario first. Device A is establishing an HTTPS session with the ArubaPedia website using Chrome. The ArubaPedia web server sends the certificate shown in the exhibit. Question is, what does the browser do as part of validating the web server certificate? So as you already know, web browser always find the issuer, then they will take the issuer public key and then validate the end entity web server certificate signature using the issuer public key. Let's see, we will have the similar answer to that. So answer A, it uses the public key in the DigiCert root CA certificate to check the certificate signature. So this answer is not correct. Why it is not correct? This certificate for ArubaPedia arubanetworks.com issued by DigiCert SHA2 Secure Server CA, not by DigiCert root CA. Because of that, this certificate signature will not be validated using DigiCert root CA public key. That's why this answer is not correct. Answer B, it uses the private key in the DigiCert SHA2 Secure Server CA to check the certificate signature. Private keys are never exposed to the end users or end entities. Because of that, this answer is totally wrong, because web browser always use public keys to validate the web server certificate. Answer C, it uses the private key. So again we have private key, but let's read the full answer. It uses the private key in the ArubaPedia website certificate to check that certificate signature. This answer also wrong, because private key never exposed to the outside world. It will be private and secured in the organization. It will never be exposed to the outside world. So answer C also wrong. Answer D, it uses the public key in the DigiCert SHA2 Secure Server CA certificate to check the certificate signature. So this is the correct answer, because the certificate was issued by DigiCert SHA2 Secure Server CA, and web browser will use DigiCert SHA2 Secure Server CA public key to check the ArubaPedia arubanetworks.com certificate signature. So this is the best and correct answer for these questions. So let's move to the next topic. Topic number 4, end user device certificate. So in an organization, there are two types of devices: domain control devices and non-domain devices. So using Windows CA, we can push certificate to only domain control devices. Microsoft Windows CA is a common option to issue certificate for domain users. GPO, Group Policy Objects, can set up to push certificate to domain join devices and users, only domain join. So Windows CA and GPO is only able to push certificate to domain join devices and users. So what about non-domain devices? So there are two options for non-domain devices. First option is mobility device managers, but it has its own limitation, because MDM can manage mobile devices and can push certificates to those devices. So MDM can only push certificate to mobile devices. What about Aruba ClearPass? ClearPass can issue correct certificate for any device using its onboard module. Onboard can integrate with multiple CA. Onboard can act as an intermediate CA or root CA. So the good thing is Aruba ClearPass. ClearPass can issue correct certificate for any device. So it doesn't matter it's domain control device or unmanaged device, ClearPass can issue certificate. So let's look at the sample question, which correctly describes a way to deploy certificate to end user devices. Answer A. ClearPass Device Insight can automatically discover end user devices and deploy proper certificate to them. So ClearPass Device Insight is not the proper module to push certificate, it is the onboard module. So answer A is correct. Answer B. ClearPass OnGuard can help to deploy certificate to end user devices, whether or not they are a member of a Windows domain. Again, ClearPass OnGuard is not the module to deploy certificate, it is onboard module. ClearPass OnGuard is to validate device posture, device health validation. So answer C. In a Windows domain, domain group policy objects, GPOs, can automatically install computer but not issue certificates. So answer C says, in a Windows domain, domain group policy objects, GPOs, can automatically install computer but not user certificate. No, GPO can install computer plus user certificate. So answer C also wrong. Answer D. ClearPass Onboard can help to deploy certificate to end user devices, whether or not they are member of a Windows domain. So answer D is the correct answer, because ClearPass can push certificate to any type of device, either it is Windows domain control or unmanaged device. So that's the end of the class today. I hope you enjoyed the class and see you next time. Thank you. Okay, that's the end of today's class. Thank you all for attending today's class at 591 Lab. We hope you found the material informative and helpful. Remember, practice is critical to mastering any new skill. So review the course content and keep practicing with 591 Lab help and support. If you have any questions or concerns, please don't hesitate to contact us. We appreciate your participation and look forward to seeing you in our future classes. Have a great day. Thank you.